All right, for these examples, we want to determine the sign SIGN. Okay, now be careful here. Do your best to determine when I'm trying to say sign SIGN and sign SIN. Okay? That might get a little confusing, so do your best to differentiate between it. All right, now number one, when we're trying to figure out the sign, we first want to identify what quadrant does this ratio lie in? Or what quadrant does this theta land in? So it's of course always useful to draw out our coordinate plane. And you're going to want to keep writing it down until it sticks. Okay, so it's our first time doing this. You're going to want to write it down. Now, top right is quadrant 1. Top left is quadrant 2. Bottom left is Q3. Bottom right is quadrant 4. We've got our ASTC, or all students take calculus, to help us remember which signs are positive. And now we also want to remind ourselves what degree measures lie on our axes. So this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees here. And don't forget, if we go back up, this is 360 degrees. All right, so looking at 192 degrees. This angle, if drawn on this coordinate plane, will lie somewhere between 180 and 270. And it would look something, probably like this. Okay, how do I know? Because whenever you draw angles on a coordinate plane, we always start at the 0 degree side and go counterclockwise to meet that angle measure. So 192 degrees lies in quadrant 3. But now looking at which value is positive in quadrant 3, we know its tangent is the only one that's going to be positive in quadrant 3. So this tells us that sign will be negative, sign of 192 degrees will be negative. So when we write this out, we could say sine of 192 degrees is less than 0, meaning it's negative. Okay, you can use your calculator to verify that that is indeed a negative value. So let's throw it in, sine 192. Are we in degrees? Yes, we are. And it is indeed a negative value. Awesome stuff. And that's all we're doing for these examples. So again, what just happened here? We redrew our coordinate plane, labeled our quadrants, and reminded ourselves ASTC, all students take calculus, because this helps us remember which ratios are positive in which quadrants. Then we took our degree, identified which quadrant it lied in, and we were able to determine the sine, SIGN, of the given value here. Finally, we could use Desmos to verify our answer, and that's that. So let's do it again for number 2. Okay, so number 2, go away calculator. I don't need you right now. Let's draw our coordinate plane. One, 2, 3, and quadrant 4. And remember, Q1 is all, Q2 is S, meaning sine, Q3 is T, meaning tangent, and Q4 is C, meaning cosine. All right, so be careful here. Now we want to remember that this is our 0 degrees, 90 degrees, 180, and 270. So if we are to draw 300 degrees, okay, also 0 degrees can also be a 360 degree here. So looking at 300 degrees, we already know that that would lie somewhere in quadrant 4, probably looking like this. Yeah, I'll say it looks like this. And the reason why it's drawn that way is because if we start at 0, right, if we start on this line here, drawing 300 degrees in a counterclockwise motion, we will end up at that part there. So we know we would land in quadrant 4, and in quadrant 4, C, or cosine, is positive. So what did we determine? Cosine of 300 degrees, this is in quadrant 4. In quadrant 4, cosine is in fact positive. So when we write this out, we get cosine of 300 degrees is greater than 0, meaning it is positive. I should also box my answer above because that is the final solution that we're looking for here. Okay, now let's use Desmos to verify. Here we go. So I want to verify cosine of 300 degrees. I'm in degrees. I'm going to throw it cosine 300 is in fact positive. Woohoo! There we go. So that's how we figure out the sine of our ratios given their angle measure.